Very few differences. Okay, this is not part of the graph. That's why I didn't graph it as a solid. This is just a vertical asymptote, this. Vertical asymptote. So the graph is this, of course, these two pieces, and that's f of x, and that's f of x. Awesome. Now, of course, this is our 3. We got stuck with 3. Doesn't matter. So I'm going to ask for the first one. So I'm going to call this A, and this B, and this C. For A, the limit as x approaches 3 from the left of the function, and the limit of the function as x approaches 3 from the right, and the limit as x approaches 3 from either side. We're talking about trend, tendency, not values. That's what this operator is calculating. It's not the square root, it's not squared, it's not natural log. It says, let's find where this function is going when x does this.
I think 3.
So where is the tendency of the function? Where is it going when x approaches 3 from the left?
Infinity.
Very good. Awesome. Follow my marker. As x gets closer and closer to 3, look what the function is doing. From the other side.
Negative infinity. Negative infinity.
From either side simultaneously.
Doesn't exist.
Excellent. Don't be intimidated by those who answer. If you have a question, stop me. It's your obligation to do so. Yes?
I have a question here.
Yes?
The first A is toward from negative. This is positive infinity or negative infinity?
This is positive infinity. This is negative infinity.
Oh.
We are talking about the y values. We are talking about the tendency of the function. Is that okay,
No.
Tess?
Yeah, it's okay, but when we have to start from the down or we have to start from the top?
As x gets closer and closer to 3 from the left, follow the function, follow the function, follow the function. We follow the function.
Okay, I get my answer.
Better?
Yep.
Perfect.
Thank you.
Okay, now in part B. The limit as x approaches 3 from the left. The limit as x approaches 3 from the right. And the limit as x approaches 3 from either side.
I think if I understand, positive infinity, of course, and infinity.
Correct.
Positive infinity.
Yes. All these are basically DNE. And these are DNE as well. But we cannot write DNE. I cannot write DNE. But they are all DNE because these are not numbers. I have to specifically write infinity in that case, and negative infinity in this case, and DNE here. All these are DNE, but I cannot write DNE because they're not numbered. That's why they're DNE. I have to write infinity, infinity, and both of them are infinity. What will you write for C? The limit as x approaches 3 from the left. limit as x approaches 3 from the right, and limit from either side.
All negative infinity.
Negative infinity for all of them, but you know they're basically D and E, but I cannot write D and E.
Why is it that in example A, the x to the 3 is D and E, but in the B and C examples, it's not?
Perfect,
Because it's not approaching,
Perfect.
it's just 3.
perfect. 3, x approaches 3 from either side. What do I write?
Well, I mean, when it approaches 3, then the answer is the y,
What is
2
the
or
number?
5.
So what is the number? You have to give me one number. As x approaches 3 from either side, please give me one number if you can.
You can't.
Good.
Oh, okay, because there's 2 different.
So now here, as x approaches 3 from either side, give me
One number.
one something, whatever it is. Give me one. Can you?
Infinity or negative.
You cannot. One.
Right.
I said one.
Okay.
Can you give
Got
me
it.
one? Excellent.
No.
Good. Awesome. Now I'm going to share my screen and look at a few examples. Where is my book? Here's my book. And I wanted to go to page 112. If they allow me to. Where's my keyboard? 112. Okay, so I would like us to choose a graph. You choose. Any graph that we want to work on to look at these limits. We have 1, 2, 3, 4 graphs. So please choose one. If not, I will. Okay, I'm going to choose this one. Can anyone, for number 25, can anyone tell us what is the limit from this function, uppercase f, as x approaches -3 from either side? -3 from either side.
Five.
Excellent. So thank you. As x approaches -3 from either side, follow the function, follow the function, follow the function. Both sides go to 5. I'm not saying that the function value is 5. It happens. I'm asking what is the function approaching? What value is the function approaching? And it approaches 5. Okay, let's see, 29. The limit from either side of 4. Either side of 4. 2. Do we all agree with 2? As x gets closer and closer to 4 from either side, follow the function. It approaches 2. How much is f of 4? Can anyone tell us f of 4? Now I'm asking about the value, not the tendency. So what is the value of the function at 4?
2.
The value of the function at 4
Doesn't exist.
does not exist. It's an open point. The function does not exist here, but we don't care. As long as both sides approach 2, the limit of the function at 4 is 2. Okay, what about the other side, or the left-hand side of -2? The left-hand side of -2.
I have a question.
Yes?
So how would you answer 27 right there? Could you just but does not exist?
Of course.
Okay.
So the left-hand side of -2, what is it?
Doesn't exist.
The left-hand side of negative 2.
And 4.
4. The right-hand side of negative 2.
2.
2. Now from either side of negative 2, what will you say?
Doesn't
That-
exist.
Exactly, it does not exist. Very good. Are we okay with this concept?
Yes.
Do we understand this concept? Let's also look here. The left-hand side of negative 3. Left-hand side of negative 3, the limit is?
Positive infinity.
Awesome. The right-hand side of negative 3.
Some kind of a negative.
Good. From either side of negative 3 now.
Not exist.
Exactly. Because you can say, I don't know. If it's I don't know, it must be DNE. Good. Awesome. I would like to look at graph each function and then find specified limits. I would like us to refresh our memory on the piecewise defined function. Let's choose a problem from the piecewise defined function, either here or here, and then answer a question and move on. You choose. It's a good practice.
73.
Which one?
73.
73. So let's work on 73. Allow me 1 second to copy it. I think I'm on page 5. You said 73. I'm going to copy it. Okay, so we have g of x, and this is on page 114. Please remember to redo the problems we do in class. Please, I'm begging you. As you know, I became good at begging. Okay, so before I even, well, let me copy that too, so I don't have to go back to it. So x approaches 3 from the left. X approaches 3 from the right, and from either side, of course. Good. So can anyone refresh our memory? How do we start when we are asked to graph a piecewise defined function? What do we need to do first? Where is this, our starting point? What do we always do when we look at a piecewise defined function?
Find the domain.
Yes, awesome. For every function, our first step is change this into interval notations. So excellent. How do I change this into an interval notation and then this? Anyone?
What was the question?
How do I change this in an interval notation? I need the interval notation in order to put it in and find the domain.
So negative x plus 4 equals 0.
Negative infinity 3, interval notation. And this one?
3 to positive infinity.
Excellent, with parentheses. Good. Can anyone now give us the domain of this function?
Union of both.
So what is the domain?
Would it be negative infinity to 3 union?
Awesome. Yes. Yes. Negative infinity 0, 3. And infinity. Awesome. Function is not defined at 3. We do not have the equal symbol anywhere. Just let me make sure. Did I copy it correctly? Yes, I did. Okay, I have a chat. Thank you. Okay, good. Okay, so from negative infinity to 3, if you remember, I always do this. I write negative x plus 4. And then from 3 to infinity, the function I need to use is x minus 3. Of course, these will be open points. There is nothing I can write here, nothing. Function is not defined at 3. Okay, so I'll plug in 0, I get 4. I'll plug in 3, I get 1. You can say you cannot plug in 3. And it's true, you're right. If you say that, it's correct. I'm not allowed to plug in 3. But if I'm not allowed to plug in 3, then I have to plug in 2.999999. Who wants to do that? So here I plug in 3. I shouldn't, but then I have to plug in 3.0000001, and nobody wants to do that, right? And then 4, and I get 4 minus 3 is 1. I only need 2 points because they are both what type of functions? Linear. Excellent. Thank you very much. Perfect. That's all I need. I will graph them in 2 different colors. Of course, you do not have to do that, but I do that to remind my students that if they graph something like this, I cannot even look at it because by the vertical line test, this is not a function. So I will graph them in 2 different colors. I'll use this orange, whatever the color is. I'm not very good with colors. 0, 4, and 3, 1, 2, 3, 1. Done, and I put the orange down. So now I will use a new color, 3, 0, 4, 1. If I make the error to extend this to this side, and if I make the error to extend the orange to this side, I get 0 for the graph. So now I'm asked these things. I don't really need to look at the graph. Of course, I'll uncover it in a moment. These are my props. I have the limits here. The limit as x approaches 3 from the left, and the limit as x approaches 3 from the right. I don't even need to look at the function. Can anyone tell us what is the limit from the left?
One.
Very good. What is the limit from the right?
0.
Of course, these are the limits. And what is the limit from either side?
Does not exist.
Of course. Excellent. Great job. Any questions on this?